A wheel with radius 3 meters rolls at 13 radians per second. So this is how fast the wheel is rotating since it's in radians per second, an angle measurement. We want to know how fast a point on the rim is rising, how fast is it moving up, when the point is pi over 3 radians above the horizontal. It's really going to help me to draw a diagram for this question to see what's going on. It's like, here's my wheel. For starters, what does above the horizontal mean? That's going to mean if you draw a horizontal line that goes through the center of the circle. So if your point, let's say it's moving in this direction as the wheel is rotating, pi over 3 radians above the horizontal means we're going up until the angle here is pi over 3. So I'm going to draw this spot as the location of my point. So there's the point. As the wheel rotates this way, it has an upward component. How fast is that upward component changing? I'm going to start labeling things that I know from the given information. For starters, I was told that the radius of this wheel is 3 meters, so I can draw this as 3, like that's fixed. As this point is increasing, there's an angle in here that's changing, so maybe I'll label this angle as theta. And since I want to talk about the upward component, talking about how the point is rising as it moves in this direction, I want to know something about the distance from the horizontal up to the point. So I'll draw this in here. And maybe I'll call that horizontal distance y. So in terms of what I want to know, we know something about how theta is changing, and we want to figure out how is y changing. So I need an equation that connects these three things, these two variables, to this number. This is a right triangle, and I think we can use sine to help us figure this out. Sine of theta is going to be equal to the opposite over the hypotenuse. So I'm going to write that down. Sine of theta is equal to y over 3. This is an equation that connects the angle to the height y. And once you have an equation, you can take the derivative of it to figure out, well, what's the rate at which y is changing? So step 1 was draw a diagram. Step 2 is connect the variables that appear within your diagram. I think I'm going to multiply 3 to the other side of this equation and write this as 3 sine theta is equal to y. Okay, I want to know dy dt. That means I have to differentiate both sides with respect to t. I'll start with this side. I'll copy down the 3, and I need to multiply by the derivative of sine of theta. The derivative of sine is cosine of theta, but since we're multiplying with, or we're taking the derivative with respect to t, I need to multiply by d theta dt. On the other side of my equation, I have to differentiate this with respect to t, and that's perfect. That is dy dt. So the question is asking this: how fast is y changing when theta is equal to pi over 3? So we have like almost everything that we need. I can take this equation, I can put pi over 3 in place of cosine. The only other thing that we need to know is what is d theta dt? And that's what this given information tells us here. If you're told how fast the wheel is rotating, that is equivalent to stating how fast this angle is changing. So we know from our given information that d theta dt is equal to 13. And we want to know at this exact moment, what is dy dt? I'm going to take this information, plug it into here, see what we get. So that is, I have 3 cosine of pi over 3, and I'm multiplying that by 13. This is equal to dy dt. I'm just going to do this in a calculator since it's asking us to round to 1 decimal place. And I get 19.5. Just want to make sure that your calculator is in radians mode. So I get 19.5. And this is meters per second. That's how fast y is changing. So that was this option here.